Boom, all the way. So in this video we're going to talk about the trigonometric ratios for 0 degrees. All right, and I'm not going to do it by just giving you the answer. I'm going to do it by discussing it, talking about it, going through a particular process, a particular series of steps, so that by the time we get to the end of that series of steps, you would have a clear sense of what it means when we talk about 0 degrees. We would have a clear sense of what it means when we talk about sine 0, cosine 0, and tan 0. All right? So we start off by giving consideration to the general right-angled triangle. So in general, you have a right-angled triangle where you have your hypotenuse, you have your opposite, and you have your adjacent, and that is your theta. All right? So as theta becomes smaller, as theta approaches 0, what will happen? As theta approaches 0, your triangle will start to look like this. Right? You have your H, you have your adjacent, and you have your opposite. All right? Come look like a proper A now. Right? And you'll get to the point where the angle is so small, well, it's difficult to replicate anything smaller than that on the board. All right? So let me make it a little ridiculous now. All right? So, right angle, right? That's the theta. This is the adjacent, that's the hypotenuse, and that's the opposite. All right? So, eventually, you'll get to the point where this angle is equal to 0. And if that angle is equal to 0, what you in fact have is a straight line. That is what we mean when we talk about 0. Right? You would end up with a straight line where the hypotenuse would merge with the adjacent side and the opposite side is equal to 0. So your O is equal to 0. Right? Your opposite side is equal to the number 0. And using that scenario, we could derive all the trigonometric ratios for sine, cosine, and tangent of 0 as follows. Well, O equals 0 and A is equal to H. The adjacent is equal to the hypotenuse. All right? So therefore, the sine, change the color ink here. So therefore, the sine of 0 degrees, or we could just say sine 0, would be equal to opposite over hypotenuse. Of course, the opposite is 0. So your sine of 0 is equal to opposite over hypotenuse, which is equal to 0 over h, and 0 over anything is 0. Your cosine of 0 will be equal to your adjacent over your hypotenuse. But since the adjacent is equal to the hypotenuse, you will get, well, adjacent over hypotenuse means that anything divided by itself is 1, so the answer will just be equal to 1. So your cosine of 0 is 1, and your tan of 0 would be opposite over adjacent, which will be opposite over adjacent. Of course, the opposite is equal to, how become to 0 over adjacent, and 0 over anything would be, I will leave it as A here just for consistency, 0 over adjacent, which would be equal to 0. So, in the final analysis, we can say then that, and I'm going to switch back to red ink now, we can say that the sine of 0 is equal to 0, the sine of 0 degrees is equal to 0, the cosine of 0 degrees is equal to 1, and the tangent of 0 degrees is equal to 0. All right? So, right, we explain what it means to have theta being equal to 0. When theta is equal to 0, you will effectively have a straight line where the adjacent and the hypotenuse converge into 1. It means that you'll have no opposite side. The opposite side will converge to 0. And if you apply the regular trigonometric ratios to this particular situation, this here is what you will get, and this here will be the result that you would get. All right? So we can now have this down as 3 results that we need to be aware of. The sine of 0 is 0, the cosine of 0 is 1, and the tangent of 0 is 0. All right? So, you check that out, you pause appropriately, and take your notes. So, in the next video, we're going to deal with what it means to have the sine, the cosine, and the tangent of 90 degrees. Yeah? So look out for that.